So any more questions on that one?
Question on do you want just a center line, or do you want the actual bolt hole?
Yeah, sure.
Show the hole?
Yeah. All it is on that hole, I gave you both. All we're showing on those bolt holes, the way I usually do it is once I've got my angle drawn and laid out and everything, remember I do it like I showed y'all with just a bunch of offsetting lines, bunch of trimming, stuff like that. So you've got your beam on there. You offset your beam down 3 inches, offset it down another 3 inches, another 3, however many holes you have. Move it, stretch it, whatever you want to do to get it through there. But all I do is offset that first one 13, 30 seconds. Why 13, 30 seconds, Mr. P? I told y'all our hole size was 13/16 diameter. Some of y'all look like y'all are off or not sure what y'all are doing there. So our standard size, that's what we're representing is that hole through there. So I can offset it 13, 30 seconds, do a solid hatch, erase any and all lines I don't need. And just copy that down.
Mr. P, I have a question.
That's how I usually do it. Keep in mind that if you hatch all 3 of those at one time, they're all connected as one hatch. You can't just like move or copy or something.
Okay, I know
You can, but it takes all of them.
You have told us like it has to be 1/4, right?
Correct. On the left end, yes, it's always 1/4.
In what circumstances is it 3/8? Because there was one assignment that it was 3/8.
No, the 3/8 I was showing you was your angle thickness right here. So just the angle without the beam. That measurement right there is 3/8. That's your angle on the end. And that angle has holes in it. It's welded to your beam. That is the thickness of that angle. 3 by 3 by 3/8 thick angle. That's the 3/8. The end of the beam is always 1/4 inch. Yes, some of y'all, I thought we cleared that up. Some of y'all I did ring up for putting 3/8 right there. Was you? I've got some more stuff to hand back to some of y'all too, here in a minute. Alright, so on the project that I just gave you, the first page are these sections. Let's go ahead and flip to the second page. I had them in this backwards sequence. On the second page, what you have there down at the bottom, it tells us plan, so we know it's a plan view, plan at elevation 18'0". Line weight didn't show up on this, so if y'all need me to, I'll probably go ahead and do it anyway, but print some more with some thicker line weight on this drawing. What we've got there is a column on the left, column on the right, so you've got a column on the left end of that beam down there. We're attaching to the web. You've got a column on the right end, we're attaching to the flange. So this is one of the beams that you will be detailing right here, a W14 by 61. That W14 by 61 stretches from the column web of a 14 by 48. Man, the graphics on this stuff, look at that 6 right there. I might need to restart it in a little while. I think cleared it up. RE and spacebar did it. So we're attaching to the web of this column. On this end, we're attaching to the flange of a W14 by 61. That beam, it says plan at elevation 18 foot 0. So when you look at some of the work that you've been doing and some of the handouts that I've been giving you and you've been looking at, you will notice that on the beam we normally show the elevation right there on the left hand end. So I haven't been having y'all show that because we haven't been having a given elevation. We've just been having, here's a beam, here's a column, here's a column, here's another beam. We've just been having those simple guys just floating out there in space. Were they at 50 foot above sea level? Were they 1,000 feet? Didn't matter. We were not concerned about elevation. So that is going to come into play on your next project. You will need to show me right there that elevation. So they're at elevation 18 foot 0, top of steel on those beams, 18 foot 0. So once again, on this end, we've got a column that is in this position in real world. Remember, that's a plan view, so we're looking down on it. We've got a column over there. Our beam's attaching to it at an elevation of 18 foot 0, I think is what it was. So visually, we know what's happening up there. We know our angle because it's attaching to the web of the column. We know our angle's gonna have, our beam's gonna have 4-inch center to center. We know the minus dimension's gonna be in the 1/8 to 3/8 range. We're not gonna have to block. On this other end, we're going into the flange of a W14 by 61. We know that it's gonna be probably 3.5 or 5.5 center to center the majority of the time. That's what I told y'all. We know that it's going to be about -7 inches. And it's going to have some holes out here, similar to that one that we were just looking at. We know that this one right here, W12 by 30. On this end, it's attaching to the flange of a column, so we're assuming it's going to be 3.5 or 5.5 center to center. We know the minus dimension is going to be about -7 inches because it's a W14. We know on this end it's a beam-to-beam connection. We know that we're going to be doing some blocking. We know it's going to be 4 center to center. This one is a W12, that one's a W14 that it's going into, so we know it's going to be just blocked on top. So that's some of the things that we steadily start instilling and building as we work our way through these. Each week we've added a little bit more since about after the second week. The first couple of weeks was just, let's go through it, same thing over and over and over. And then we started branching out, adding a little bit more. But it's still, there's not a lot of rules that we said, not a lot of things that I told you that we can just look at and kind of see, kind of assume what's happening there. But we know on this end, like I said, it's going to be 4-inch center to center, so we can build and design this member, detail that member without having to detail that one. Because we know the center to center. Once I turn the dimensions on, we'll have a distance from the center of this column to the center of that beam. We know on this end we're going to subtract 2 inches. We know on this end we're going to be subtracting about 1/8 of an inch to get that tail dimension. Remember, these tail dimensions are just showing this measurement right here. Without doing a bunch of dimensions. So like I said, right here, we know that we're already going to be subtracting 2 inches on that end. Over here to where that dimension goes, we don't know. Maybe we're attaching to the web of the column. Maybe we're attaching to the web of the beam. Maybe we're attaching to the flange of a column. Doesn't matter, we still have to subtract our way back to the face of our angle, the heel of that angle right there. But we're gonna have that minus dimension written down there anyway, so it's not like we have to look up a bunch of different stuff. That's part of the things about showing your work that I always liked in structural, because your work is on there. It's not just here, go build this. Lots of times I could look at it and say, that math just doesn't look right, before it ever leaves my desk and goes to the checker. 10 foot minus this equals 5'3". No, I think I did some math wrong. So doing this work on here on this column, on this beam, we kinda already know what's gonna happen. This W12 by 30, like I said, one end's a beam to beam connection, block top only, the other end's beam to column flange connection, about -7 inches, 3.5 or 5.5 center to center, about -1/8 to 3/8 on right here on this end. Like I said, I don't remember if this one's in Blackboard or not, so I'm gonna make sure everybody has it printed out before y'all leave. But this is what you're gonna be doing. You're gonna be detailing that beam, similar to this right here. Showing me tail dimensions, showing me measurements to the first set of holes in that pattern. Giving enough information for somebody to take a tape measure and a bunch of steel and be able to build that.
On this drawing that you gave us, I think you were missing a dimension at the bottom. That would give us that 9 foot, 9 3/4 that you had on the previous one.
The one we were just now looking at,
Yes.
this one?
Yeah, you see how you have a 9 foot, 9 3/4?
Uh-huh.
So you know where to draw the 4 bolts in the beam. And the paper you gave us, we don't have that dimension at the bottom to know where to draw it on the beam.
Yeah, I didn't show that dimension. I'll revise that and give y'all that measurement in a little while. Yeah, I left that one off, maybe. So yeah, I'll check that in just a second and give that to you. And in fact, while we're talking about it, let's go ahead and check it now. So show a measurement from the center of your column to the center of that beam. And that measurement is not 4 foot over 5/8. That measurement is 4'0". I'll turn it on and add that dimension to this page in a little while. But from the center of this column to the center of this beam, a distance of 4'0". Go ahead and turn those on now, do that. So everybody got that? Alright, so this drawing is the plan view. We're looking down on it. We're looking down on 3 columns and 2 beams. Where you see these sizes drawn, that is going to be the left end of your picture. Does everybody understand that? Where I show you the W shapes on this page, that will be the left end on your detail. So the other drawing that I gave you showed some sections. Not really for what you're doing with the beams, more for the column information.
So are we drawing the column too?
Yep, I had told you, but yep, kind of blew my surprise, but yep. So you've got a total of 3 columns. So on that first page, I called out a section AA. On that, well, I'm not gonna argue about which page first and second. On the plan view page, I called out a section AA and a section BB. On this page, you will see section AA right here. Here's your column on one end. Here's your column on the other end. The way these are represented is the way you will see them in industry. If we're looking at the flange of the column, so if I were to walk up on this stuff out in the real world, I would be looking at the flange. I'd be walking up looking at it like that, just like when y'all walk in that door looking at this piece right here. So what we normally do is we show them the flange outsides and a center line. If we're looking at it kind of like y'all are, if y'all look up here at these to where you can see the flanges sticking towards you, you're seeing the web and the flanges are sticking out towards you. We show the double line for the flange, similar to what you drew on your column detail the other day. So this is section AA. This is what it would look like if we were to walk up to it out in industry. You would have a column on this end, a column on this end sticking up, a beam spanning between them. So normally when we show that beam, we don't show it all the way to the end because we're not going to detail that connection. That's where the drafters come in, the detailers come in. We're going to detail that connection. We're going to show all of that. So what they usually do is just put some breaks right there like this. Sometimes you'll see them like that. Sometimes you might see them like this with the Z break. Lots of times you'll see them with the Z break. Something like this. Sometimes you'll just see them with that spline like that. But that's all that little spline is doing, is saying, all right, right in this area, here's your two flanges. So does everybody understand what you're looking at in that view? We're looking at that beam going across there. There's that beam going across. We're just not showing the end of it. Does everybody understand that?
That's how we're drawing it with the splines on it?
No, you're drawing it just like you've been doing.
All the
Yeah.
way?
Yeah, this is just the erection drawing. They shortcut stuff. And then we've got a beam that's attaching right there. But yours isn't gonna have that beam right there. Your W14 by 61 is gonna have a hole pattern right there. You're gonna have a holes 4 inches apart, down 3, 3, 3, however many rows you need. So that's similar to what yours will look like, but not really. Yours is gonna look more like this. You're gonna have your angles on the end. You're gonna have your 3, 3, 3s. You're gonna have your elevation. I'm not worried about the AAs. You can just go straight to center and gauge. But you're gonna have all that. You're gonna have your quarter, your minus dimension, your tail dimension. Same stuff you've been doing. Your overall, your minus dimension, your angle stuff, all of this. You're gonna have holes out in the center. You're gonna have your label below it. But on the erection drawings, it's just here's what it kind of looks like, giving you an idea. Once again, the sooner you can visually see that, the sooner you can understand what all these lines mean. So this is section AA. If we were to walk up to it, once it was built out in the field, this one on this side would just be looking at the flat of that flange, just like if you were to walk in the classroom and look at this guy. This one over here would be similar to walking up, or similar to what y'all are looking at when you look up here at these columns. But once again, you walk out the door, every time you leave this building, there's some right there in front of you that look just like this. You can walk up to it and say, okay, there's the flange side. That's what it looks like. What if I walk around over here to this side? That's what it looks like with the little flanges. You know, utilize that stuff, people. I'm stressing that so much because I know what struggles I went through. All because I was just, didn't have the opportunities, I don't think, but I was also too lazy. I didn't go out and investigate. I didn't go out and try to find stuff. But once again, he never even so much as pointed to that thing right there. This is a classroom I had it in. Not that I remember. I wasn't always in my right mind. Here's section BB on this side. If we were to walk up to it and look at it, we had that beam that it was connecting to on that end, beam to beam connection. And I should have shown that stuff coming down right here, but I didn't. Sorry about that. got lazy. So we're connecting to a beam on one end, column flange on the other end. That's this guy right here. We're connecting to a beam on one end, column flange on the other end. So that's what it would look like right here if we were standing right here, looking back at that beam right there. Section BB is what it would look like. So once you come over here, you will see that each one of these have an elevation at the bottom of the base plate. Each one of these show you an elevation at your beam top. How tall is that column? Well, if this line right here is up at 18'0" in real world, and this one right here at the bottom of this is at 10'0" in real world, anybody want to take a guess on how tall that unit's going to be when it leaves the shop?
8 foot.
8 foot. Bottom is at 10'0" in real world. Top is at 18'0". We don't need to take measure to measure. We've got the information right there. They don't have to show us that formal dimension. When you get out into petrochem work, you will be working off coordinates and elevations. North, south, east, and west coordinates. Some of y'all may have had me for basic pipe. You may have already heard that. That's how we locate and do it. We're not going to show all of these dimensions, just cluttering up these drawings, because there's going to be enough information that we're trying to show on that drawing. Typical example of an erection drawing. That would be a plan view right there. That is a plan view and some sections. These are the elevations, the outside views of that. So there's too much stuff going on for us to try to show everything on these drawings. So we show enough to give them the information they need, to give them an idea of what it would look like if they were to walk up there. But if you go find somebody that's been in accounting for 30 years and you say, here, go find this out there. What? Well, go find what? What is that? You as a drafter, when you walked in here, if you were like me when I first walked in here, you were like, what is that? Just a matter of going to look and investigate. You've got them sitting on that desk, hold them in your hands. Down here at the bottom, we've got your section C. So if I turn those dimensions back on, section C is just like that last column you did. This is a section looking down on that base plate. This one says section C, this one says section C similar, this one says section C similar. The reason being is that if you were to cut this section right here, if you were to take those objects just like they are and say, let me look at it right here, that is the way that section looks. These other two columns are turned 90 degrees. So if I were to come down here in this view and say, well, instead of saying the section C similar, I'm gonna do two sections. I wanna get a little bit extra money out of this. So I'm gonna tell my boss that I drew it twice. I'm gonna call this one section D. And then I'm gonna come in here and just flip this guy around. There's my section D. Why did I say similar on those other ones? Because it didn't look exactly like that. That column was turned 90 degrees on those other columns. The section wouldn't have looked the same because of the column position. But measurements were all the same. It's just a matter of rotating that guy right there. So having that section C similar right there, knowing what those I-beams look like, knowing that those two parallel lines right there represent the flange, knowing that because we saw it in this view right here, clearly showing that it was attaching to the flange, so we knew what was happening. Right there, that's attaching to the flange, so we knew what that was. Instead of drawing or doing the extra work to put that out there, which wasn't much, we just put notes like similar. So your next assignment that is due 1 week from tonight, which is the same night of your finals, same night as your notebooks. 1 week from tonight, you will be doing, let's say, both beams in any 2 columns, because they're all 3 different. It's not like you could detail them and say, okay, quantity of 2. There's something different about each one of those columns on the detail. So 2 beams, 2 columns, 3 sheets. You can fit 2 beams on a sheet, but you're not gonna be able to, yeah, you might be able to fit both columns in 1 sheet. Give it a shot. So you're gonna have 1 beam that's similar to this, column on both ends, holes in it. You're gonna have another beam that's similar to this with a block right down here somewhere, a block in because it's beam to beam. So that's your 2 beams. Perfect example of those in what you've been working on. Here's a perfect example of your column. Just once again, different measurements, different locations possibly, but this is a perfect example of the information you will have to be showing. So any questions on what you're working on to be turned in either next Monday, which is the assignment that you're working on now, the 3 sheets, 6 details. That's for next Monday. And then for next Thursday, 1 week from tonight, 2 beams, 2 columns, notebooks, finals.
I got a question about the notebooks. Whenever you, I guess the first day of class, you told us to do 5 tabs, but I don't know what's a handout, what's an assignment, and what's a project. I thought they were all the same thing.
No, I can give y'all that info. Previously in Blackboard, it would tell y'all, but I think it was about a year ago, maybe back in the spring semester, that someone said, hey, they don't show us those anymore. It doesn't show what section it goes in. So any questions about this part right here, about what your homework is before I leave that? All right. So in your Blackboard, I put in there, you're correct about that. It shows 5 tabs. So if you want to make note of it, I will tell you what I show in each one of the sections so far. So your sections for handouts, if you printed all that stuff in Blackboard, you can stick it in there. There's a section in your notebook for handouts. When it's stuff like last week you did the test, you had a handout that you worked off of, and then you had a handout that you turned in to me with the answers. This is a handout. You didn't do any work on it. It was not a test, it was not an assignment, it was a project. But in my eyes, the graded test in your notebook would be the best place for it. Why would you want to put one of them in the handouts, one of them? That's my thing. If I go to look back at that a week from now, while I'm studying for my final, a month from now, 6 years from now, when the boss comes in and says, hey, does anybody know how to detail structural? We just got this little thing we need done. Something to reference back to. If you want to look at that sheet and say, okay, there's the answers I got. Where did I get it from? You probably want those 2 to be together. But once again, if this one is in the handout section and this one is in the test section, I'll find them. I've got a checklist. So that's the handouts. I don't go through the handouts section. I don't go through the notes section unless I don't see something in the assignments, projects, or test sections. Then I go search those other sections. If you didn't print all them handouts in Blackboard, and you've got stuff like this with the project, with the assignment, with the test, I'm not gonna go into those other sections. If you don't take notes, as long as your stuff's in the other sections, I'm not gonna go in your notes section. I told you I didn't require that you take notes, that's strongly recommended, but it was up to you. So the 3 sections I'm gonna be looking for stuff in. In your assignments section, I have that first little project that y'all did. It was called Beam Exercise 1. That was this guy right here. You just had the little half beams. That went in the assignments section. And I think this was the next one right there. Those beam detail 1A, yes, that's your beam detail. That's the only other thing that I have in the assignment section in Blackboard and in the grade book. So that will translate to your notebook. For the projects section, you had another exercise that you did similar to that one. The first one that you filled in this little chart on, beam connection 2, beam detail 2. This one showed the whole member with the beam to beam connection on one end on some of them, 2 ends on the other ones. Actually, no, this is beam connection 2. Yeah, this is beam connection 2. This goes in your projects section. I'm gonna have to find beam detail, the other grade, for your assignments. So right now for your assignments, you've got this one right here. For your projects, you've got this one right here. And then you've got your 2 11x17 DWG projects that you've done. Beam details 1 and 2. Those go in the projects section. I'm not talking about what you're working on now. So this one right here and the 2 CAD drawings that you did on beams are the projects. I'm gonna have to look up that second assignment that you did in the assignment section to find out what it was. You also had your column detail. That one goes in the professionalism grade book section. You can stick it in either the assignments or the projects. It doesn't matter to me.
What's the purpose of the notebooks if you've already graded the papers, handed them
To
back?
see if you can keep your stuff together and stay organized, and if I can promote you in the industry when the boss comes and says, how are they? Well, they're great till you take their work from them. It'll look good if it's on the computer.
Yeah.
But man, you don't want them to hand you anything. You don't want this person sketching or keeping track of the project. And because I'm a teacher, I get to.
No, I was just curious, cause.
That's the main reason. I want y'all to have something to go back to later, and maybe some little organization skills.
Cause I noticed that's in every class.
Mine, yes.
Well.
I can't speak for other people, but if you take one from me, I'm gonna make you keep your stuff,
Yeah.
at least till the end of the semester. I think drafters ought to be proud of their stuff. If you still got it 2 years from now and you're using it, if you still got it 2 years from now and you're not using it, you're prepared to use it if you need to, that's a good thing. As someone that works in industry. Trust me, you come in with a notebook and some previous stuff, so you got the reference to on the work, new job you're going into, you're gonna look a lot better, look a lot more professional. The person that just shows up on day one with that in their hands, their phone. Priorities. But no, I want you to do it for my class, because I want you to keep track of your stuff through the class.
Okay, I just didn't know if it was like a curriculum thing, cause